I'm giving you a hard time, buddy. You're doing fine. I was going to use this today. Because I have a new gym. New something plugged in and back, supposedly. It's the one that's actually plugged in as well. So it has a little bit more oomph, supposedly.
No, it's not. How did you know that?
All right, let's see.
I'm not.
This is supposed to work using.
Are you Russian?
Am I Russian? No. German Irish.
Really now?
I am. Are you Russian?
Yeah,
I told you.
Can you wait? You can?
Connected to CMS.
Ooh.
You
Man,
plugged it
more
in.
than one word, please. More than one word, like say it.
That's a lot. What?
That's one word.
That's how are you doing?
It will say something wrong.
Oh, press the Windows key plus K.
Yeah.
What do you say?
Hello, my name is Sophie.
That is so cool. That is so cool.
Dude, I don't like Russians.
Your mom is
Bro,
so funny.
I don't like Russians.
I don't mess with
They
them,
freak
bro.
me out, bro.
They do freak me out. Their voices are super weird.
Yeah, her mom.
What up with that?
Her mom has like an.
It's just a thick accent.
Yeah, I know.
Oh, Josh, I gotta
Give
show
me
you a
that.
picture real quick.
What is it?
Hey.
Oh, it's
Yeah.
terrible.
Sorry. Do I come over there?
No,
Oh my god.
Holy cow.
I saw the video yesterday. Like he was saying that thing as
That is so funny.
All right. Questions? Questions from last night's homework on page 139, 140.
I got him.
8.
Number B.
Number 8. I'm in.
Number B.
Number 8.
Thanks.
Okay, so they want us to solve each system by graphing, right?
Yes.
So, top equations already set up in slope-intercept form. They're actually both in slope-intercept form. It's just that this one's out of order a little bit.
Yes.
Can I change this one to this?
Yeah.
Does that make sense?
Wait.
Can I just flip-flop it to make it easier? All right, so I'm going to draw myself in an XY axis, and I'm going to see if I can draw this the best I can. Where is the y-intercept on this one? -5?
Wait, did you add this?
I just flip-flopped those. Flip-flopped them. Took the sign with both. Because it was a +2, so I had +2. Because there wasn't a sign in front of it.
Oh.
And then -5x, so I just changed the order. Alright, what's my slope of this one in red? What's my slope?
5. -5.
No, on the one in
2.
red. 2. So from this point I'm going to go up 1, 2, and then over 1. Up 2 over 1. Up 2 over 1. Right? Because the slope keeps going. So I get to that. Is that okay?
It's a little bit curvy.
Let's go with it. Yeah, but. Alright, so now I'm going to graph this one, which is technically the same line as this, right? I just made the order different. Alright, so with that known, talk to me. What's my slope of this blue line? Or excuse me, my y-intercept of the blue line? 2? Good. Go up 2. What's my slope of the blue line? -5. So from here I'm going to go down 1, 2, 3, 4, 5 over 1. Okay, look, those 2 points are the same, aren't they? Alright, so that looks like it would be, oh, I don't know, 1, comma, 1 comma -3. Yeah, we sure can. This is an x value, this is a y value, agreed? So this is what we think our solution is. So let's take my x value and plug it in for x here, and take my y value and plug it in here, and we're going to do it on both. So that's going to be negative 3 equals 2 times 1 minus 5. Okay, so that's negative 3 equals 2 minus 5. Is that equal? So that works on that one. That means that that point exists on a red line guarantee. All right, so let's do the same thing on this one. Okay, so I take my x and y value. I'm going to do this one over here. More room. So I have negative 3 equals negative 5 times 1 plus 2. Negative 3 equals negative 5 plus 2. What's negative 5 plus 2? I hope it's negative 3. So it works on both. So is this the solution? Yep, it works. All right, what else might we want to see? What other questions did you have on? Yeah.
I was just wondering, like, how to find the number C for number 10 on page 140.
Cool. Let me grab my notebook and I'll come on back. Which number were you looking at?
9.
It's
10?
C,
On number 10?
page
Oh.
140.
You got it. Let's just take a look at it. Let's actually work the whole thing. All right, so we have a word problem. Yay! So suppose you want to join a gym. Okay, that might be something people want to do. It says the Colorado Athletic Club charges $480 fee plus $40 per month. Okay, I don't know if that's right or wrong. They just made up arbitrary values, I'm sure. And then it said 24-Hour Fitness has no initial fee but charges you $55 per month. Okay, so this is problem number 10. So let's think about this. We have two clubs. We have the CAC, the Colorado Athletic Club. How much do they charge us initially?
$480
How much?
40.
$480. So they're charging you $480 just to sign up. Yeesh.
Let's do it.
Okay, and then how much are they charging us a month?
40.
40 for each month. Okay, so we'll say the cost of our membership, that would be $40 per month. So if we were part of it for 10 months, it'd be 400 plus 480, which is 880. So I'm going to just change these to x and y's. Is that okay? So that's our Colorado Athletic Club equation. So the 480 technically would be our y-intercept. I don't know if I would want to graph this one. What's kind of sticking out to you of why we wouldn't want to graph it? Yeah, that 480. Heck, even the slope of 40 over 1. Count up 40. 1, 2, 3, 4, 5. Shut up. 9, 10, 11. Shut up. 15, 16. Shut up. 19. You just missed like 19 numbers. Right? All right, so then let's take a look at the old 24-hour fitness. All right, how much does 24-hour fitness charge us initially?
55.
How much did it charge us just to sign up?
0.
Nothing. How much did it cost me a month?
55.
55 a month. So the cost of my 24-hour membership is $55 a month. I didn't have to pay anything to sign up. I'm just paying $55 every month on my credit card or somehow. What's my y-intercept on this one? 0. So I'm going to change my values to x and y, and then shoot, look at the slope I have, 55 over 1. Again, this would not be a good one to graph, even though 0 is easy to find for the y-intercept. I'd have to count up 55 and write 1. Good luck. Okay? Does everyone feel comfortable with the two equations we've developed?
Yes.
Okay, so let's make sure. Write an equation for the cost. We have that. So this is the answer to A. This is the answer to B. And then how many months would you have to join for it to be the same price? So one of the places only charged me $40 a month, but I had to put up $480. The other one's charging me more per month, but I didn't have to put anything forward. Okay? So let's see if we can figure this out. So for both of these, our X value is our months. And our Y value is our cost. Our total cost. Now let me ask you this, my friends. You think there's a lot of people right after New Year's that go and get some gym membership?
No.
Yeah.
Yes.
Yeah, and there's like a week after New Year's that every gym across the United States is full.
And then they're like,
And then people are like, oh, I feel good, I exercised for the whole week, and now I'm going to go get, back to my bad habits, right? So I like to take the week after New Year's off. Because I hate these fair weather fans going, I made a New Year's resolution. I'm going to drop 170 pounds. No, you're not.
I dropped
Yes, it
5
is.
pounds yesterday in one second.
It's possible.
So, it's possible for someone to drop that kind of weight, not necessarily just by diet. Usually they have to have some sort of gastric bypass surgery, which is actually where they do one of two things. They put a ring, they go into your stomach region, they go through your abdomen into your stomach, and they put a ring around part of your stomach so your stomach can't get big, where your food's sitting. No, it won't explode. So the food goes into a smaller stomach, or they will actually staple it shut. So,
I'm gonna go throw up.
here's kind of thing. Food comes down and it enters your stomach, and then from your stomach there's a sphincter here which goes to your small intestines, which doesn't look like a tube. It actually looks like slices of pineapple. Like literally. Like when you look at it, it's like this butterfly thing, and you pull it apart, it looks like pineapple rings. Then you take my med class. And then it has another sphincter down here, and then this goes to your ascending, transverse, and descending, and that's where it comes out the backside of you. Okay?
No.
So what this surgery actually does is they do one of two things. They either they lasso in this area right here and pull it together, so then your stomach actually looks something like this. And that's where it comes out. And so this region's not being used anymore, so now your stomach's smaller.
That's heinous.
So if your stomach, where your food is sitting, is basically a reservoir, it falls down, you swallow your food, it goes down there, it falls into a bath of hydrochloric acid, it swishes back and forth in hydrochloric acid starts breaking it down, and then it enters into your small intestines, which then absorbs all the nutrients from your food, and then actually when it gets to your large intestines, which is also called your colon, does anyone know what the job of your colon is? Yeah, not just the poop.
Just like process whatever.
Protein.
Like take out whatever the bad stuff is.
Not take out the bad stuff, it's taking out an incredibly wonderful stuff. What's the good stuff you think it takes out? No.
Nutrition.
No.
Carbon dioxide.
No.
Energy.
Why are you eating?
No. It takes out water.
Oh.
If you did not have a colon or a large intestine, you would have to drink an extraordinary amount of water to keep hydrated. Okay? That's why when you go to the bathroom, you have supposedly solid. Okay? There's your.
That's if you don't have a colon.
If you don't have a colon, you'll be dehydrated, because your colon's job is to take the processed food that went through because your small intestines is doing this. Hey, I like that. I'm going to take that. I'm going to absorb that. Hey, I'm going to absorb that. Hey, this is fat. I'm going to absorb that, and I'm going to save it for later. And I'm going to really mess with people because I'm going to make them have a big old belly and a big old booty. Okay? That's basically what your small intestine's doing. So it's taking out stuff. Now people are like, oh, so I shouldn't eat a high-fat diet with fat. No, you should. Your body needs fat. But your body, we, as here in the United States, actually tend to eat a whole heck of a lot more food than we should. So why do we get fat? Because our body sees all of this fat saying, hey, I'm going to store that for later. Hey, I'm going to store it for later. Hey, I'm going to store it for later. Your body doesn't say, hey, we have enough in reserves. So let's just let it go on.
Why can't you just poop fat?
Well, you can. It's part of it, but basically what your body's doing. So anyhow, your gastric bypass surgery will make your stomach smaller. If your stomach's smaller, you can actually eat less and you become full quicker. Okay? So that's really the main thing. If people want to lose hundreds of pounds, if you want to lose hundreds of pounds, you have this done. And it's not a reversible surgery. And it's amazing when these people get it. I don't know if you've ever come across anybody who's had gastric bypass surgery. It is absolutely amazing how quick they shed their weight. Yeah. And was it all of a sudden going, oh my gosh, you're like a third of the person I remember? Yeah, it's amazing how fast it is.
Is it like healthy to them do that? Or is
It is actually a pretty dangerous procedure, but the person who is morbidly obese is at such a high risk of cancer, such a high risk of heart attacks, strokes, diabetes. By them doing that, it allows the weight to drop so much that a lot of people get off diabetes medicine. This does not cure type 1 diabetes, which is juvenile diabetes. This will cure type 2 diabetes. If you have this done with your stomach, you no longer eat 3 meals throughout the day. You eat like a cracker. I mean, you eat the smallest meals, but you probably have 10 of them throughout the day.
So you're like anorexic.
You're full, but because your stomach...
That's major money savings.
He's anorexic.
You.
Yeah.
Dude,
What
he
can I
could
say?
have that in the Martian.
Yeah.
Think about it. He could just save so much food.
So, all right. So back to our
Space.
Hey, that's not me.
back.
Yours gone wrong.
They're burning enough that they're fine. Back to our original thing. So we talked about if you want to lose hundreds of pounds, if that's your New Year's resolution, joining a health fitness club isn't the best thing. Okay, so does everyone agree so far with what this problem is? We have a linear equation that goes with the Colorado Athletic Club, and we have a linear equation that goes along with 24-hour fitness. Anybody stuck on either one of those?
No.
So what I want to do is I want to try and solve these for both x and y. I want to get my x and my y value down here. And I said my x is months, right? And I said my y is my total cost. Agreed? Okay, so I have these two equations. Y is equal to this, and y is equal to this. Agreed? So y, I don't see any difference other than green and black for my y's up there. They're the same letter, right? What I'm going to do is I'm going to take that 40x plus 480, and I'm going to set that equal to 55x plus 0. Do I have to put the plus 0? No. So now we're here. Okay, so how am I going to get x all by itself? Subtract. So, okay, so I'm going to subtract 40x from here. I'll subtract 40x from here. So I get 480 is equal to 15x. Agree?
Yes.
How do I get x by itself? Divide by 15. Anyone have a calculator out? If so, will you go 480 divided by 15, please? 32?
I'm so classy clean.
No, you're not.
Okay, so 32 That's all from
You're
you.
still on that.
All right. So, what does that 32 mean?
That's an X.
X means what in our context of our problem?
Month.
Months. So at 32 months, you've now spent the same amount of money between the two clubs. Does that make sense? Now, if I wanted to figure out what my Y value was, because it says, let's figure out the Y value. So I'm going to take that 32, which is an X value, And I'm going to plug it into either of my x values, either here or here. Which one looks a little better? The one in the black, because I'm just going 55 times 32, right? So what? I have y equals 55 times 32. Someone have a calculator?
Jacob, you got a calculator?
55 times 32. Anybody? You can use your cell phone if you need to, or you can grab one from my back door.
Put that one down. Calculator, please.
1,000.
I hate all of you.
Get one for next time it happens.
So 1,760. What does that y value mean in the context of our problem? Yeah, it's my total cost. So after 32 months of me being a part of this thing, 32 months is close to 3 years. Agreed?
Yeah.
Because each month is 12. So 36 months, 3 years is 36 months, right? So after 32 months at either one of these clubs, you have paid $1,760. Okay? Now the letter D says, hey, what has the better deal after 3 years? Who has the better deal? Okay, 3 years is how many months?
32.
36.
36. So 3 years, that's the same thing as 36 months, right? Months went with what? X or Y? Huh? X. All right, so my two equations are this one. So I'm going to take this top green equation. I'm going to go y equals 40 times 32 plus 480. Anyone got that calculator up?
Ah,
Told
wait.
you, John.
I got you, bro.
What is 40 times 32?
My flip phone calculator. Okay, what?
40 times 32.
40.
And then add 480 to that.
32. I don't know. Okay, that's 1,280.
And then you add 480 to that. What'd you get?
Oh my gosh!
What'd you get?
I hate you.
What'd you get? 1,760.
I hate all of you.
Okay, so at 3 years into the Colorado Athletic Club, I'm going to drop $1,760. Okay, I can then also plug my 36 into here. I have 55. Oh wait, you know what? I made an error. This is supposed to be a 36, isn't it? I made a boo-boo. Help me out. What is 40 times 36, please? 40 times 36, please. Add 480 to that.
I'm gonna break all of you.
There we go. I got it right now. All right, so if I was at the Colorado Athletic Club for 3 years, which is 36 months, I'm dropping $1,920. If I want to go over to the 24-hour fitness at $55 a month, what is 36 times 55? How much?
1,980.
She's doing. She doesn't even have a calculator. Genius.
Or you can just look on your paper if you got the answer.
$1,980. Which is the better deal? Which is the better deal?
Still probably.
Yeah.
Wait,
So-
no, this problem's happening.
So look here. So, I mean, this might be a real thing that someone might choose to do sometime. You move someplace, you're like, hey, I'm going to stay here for a while, and you realize I have athletic club here, and I have athletic club here. They're both pretty close to your home. So you're kind of like, hey, which would be better? You might go check out both of them to find out who's going to give me the better deal.
Third option,
So-
you just go jog outside.
So if you decide to go with this guy, after a certain amount of time, you're paying more overall than you'd be here. So at 3 years, $1,920. At 3 years, $1,980. That's $60. Now, some people are like, dude, doesn't matter to me because 24-hour fitness has this. 24-hour. I gotcha. Okay.
It's just bike machines and treadmills and
I bet Oliver works out every day.
And it has stomach staples.
What? Yes.
All right.
He's gonna get his stomach. He's gonna
Make sure your name is on page 139 and pass that forward, please. Make sure your name is on page 139 and pass it forward, please. Jacob, will you pick up the homeworks for me, please?
Got it.
Thank you.
You think I'm Asian?
No. What? Where do you hear that?
Jacob, I'm taking one spread.
Alright.
Wake, Jackson,
Hey, can I go with you? I like your
I
homework
have a
body
question.
figure.
Hunter asked her out.
It's a ring homework.
So
I don't even remember that.
Yeah.
I know.
Yeah, I like your vibes.
It's
Mr. Right there is perfect. Thank you. Oh, beautiful.
No one knows that.
Can we drop by? Can we drop by?
You can't find it. You just went to it.
And why don't you give one to Christian? Show him how to share. All right. So, I was planning with today our lesson. We're going to look at a new concept, but I want to talk about a few things, and it goes through this packet. It's pretty quick. There's things that you're totally going to know because we've already done it, but let's just move back and take a look. All right, so we've learned graphing is one way to solve linear equations. So there's some good. So what faults might graphing have?
A faulty ruler.
Faulty ruler, or you didn't have a ruler at all, right? Yeah.
You can't always get the correct points.
Yeah, because it might be a fraction or decimal, right?
Yeah.
It might happen way off it, or like on those word problems where we had like y-intercepts that were ridiculous or slopes that were ridiculous. Most of the graphs I give you are from -10 to +10 in the x and y direction. So if I go beyond that with a graph, it's kind of hard to do to see where they cross, right? So we know this. If I had two lines that crossed each other, this would give me one solution. That means that point exists on both lines drawn. But sometimes I might have had two parallel lines. Will parallel lines cross? No, so there's zero solutions here. Okay? And then there's that one weird scenario where it's like I have this line, and then I have another line right on top of it. And that means we have infinite solutions, and that actually means I just graph the same line twice. Okay? Everyone feel comfortable with that? Everyone's happy, I hope. Can I move on?
Yeah.
Okay. Then we learned about substitution. And substitution, we had to isolate a letter on one of our equations and plug it into the other. Okay? So we either had to have one of our equations x equals or one of our equations y equals. And then we'd have to plug whatever x equals into the other equation for x, or y equals, and plug it into the other equation for y, and solve it. Once we got the one letter, then we plug it back in and get the other letter. Okay? So that was kind of yesterday. Now, some things these are all kind of set up sort of nice for us. So like this first one, like I have this and this, I can set them equal to each other because they're both equal to y. Okay, so it's like, all right, well, I need to solve this, so I can add 2x to both sides. So I get 5x, subtract 6 from both sides. So 5x is equal to -5, divide each side by 5. So I find that x is equal to -1. Well, there's part of my answer. So then I have to take that answer, this value here, and I have to plug it in either for that x or that x. It doesn't matter which one. So I'll plug it in the top one. So y is equal to 3 times -1 plus 6. So that gives me -3 plus 6. -3 plus 6 is 3. So this is one solution. Okay, I have an x and a y value. This is what we worked on yesterday. But then we might modify it a little bit and say, hey, look, this one's already solved for y. Agreed? So if I take that and I plug it in right there, I get that. This is where the y had been. I'm going to combine like terms. If I combine like terms, those are gone, and I wind up getting 1 equals 1. My x and y's went away. Is 1 equal to 1? Yeah. So this means we have infinite solutions. This would be, if I had graphed these lines, it's the exact same line on top of the other one. And then we might come across one like this saying, oh, sweet, I'm going to take this, I'm going to plug it in for y. Combine my like terms, so then I wind up with 2 is equal to 3. Did we solve the lifelong mystery that 2 is equal to 3? This is nonsense, right?
Sometimes 2 can equal 3.
So if it's nonsense, that means we have no solution. If I had graphed these would have been parallel lines. Okay? Can I move on? Or are we good? So that's kind of yesterday's, right? All right, so here's the new information we got. So there's another method. It's called the elimination method. And this works when both equations are in standard form, so ax plus by equals c, and you can't get x or y alone. Does that make sense to say that? Meaning you have like 5x plus 2y equals 7, where you have to do a whole lot more math to get x or y alone. Okay? So, these need to be in standard form. So is this in standard form? Is this going x, y, then a constant, x, y constant? What do you think? Take a look at the equations up there. So, the two equations that are up there. If I add my two equations together right now, does a letter go away? If I add 3x and negative 2x together, do I get 0? If I add 2y and 3y together, do I get 0? Agreed? So, we have to pick. What letter should we get rid of? I would probably choose to get rid of x. Because I want to have opposite sign numbers. So this whole top equation, I'm going to multiply by 2. And this whole bottom equation, I'm going to multiply by 3. I'm going to go 2 times 3x, that's 6x. 2 times 2y is 4y. Equals 2 times 8 is 16. Does everyone feel comfortable with that move I just made? So again, these are in standard form. If I added them together as a stat, they're not going to work. Now what I'm going to do with this 3 is I'm going to go 3 times negative 2x. I'm going to get negative 6x. 3 times 3y, I get plus 9y. And then 3 times 10, I get 30. So take a look at these two new equations up here. What would happen if I added them together right now? What's going to go away? X. Those cancel each other out. When I add them up, I get 13y, great, and then equals 46. Now this is a little uglier answer. This is definitely one you would not want to graph. I get 46 out of over 13. So my y value here is 46 over 13. Yuck. Does anyone want to take a shot at how I get my x value? Now the ones you'll see tonight, they're not going to be this ugly. But what I would do is I would take this y value right here. Everyone agree that's a y value? And I need to get an x value. So I'm going to take that y value. I'm going to plug it in either here or here. So let's see if I plug it in here, what it's going to do. It's going to be nasty, I know. 2 times 46 over 13 equals 8. And then you would solve this for x. And whatever that answer would be, would go right there. I'm not going to do this one because I'm not going to give you big old nasty fractions. Yes, Christian?
Why did you multiply times 3?
So I decided I wanted to get rid of the x's. So what's the smallest number that both 3 and negative 2 go into? 6. Okay? All right, so again, I'm not going to solve the rest of this problem because it's nasty. It's ugly. Okay? And again, tonight's assignment, you're not going to see that in that back thing. But let's try this scenario. So let's see if you can catch on to what we're doing. Are both of those equations up there in standard form? Everyone agree? So it goes x then y then a number, x then y then a number, right? So if I add these two equations together, if I go 5x and 3x, I get 8x. If I go negative 7y and 2y, I get negative 5y. So it's not going to work to add both of them together right now, is it? So I need to pick, do I want to get rid of x or do I want to get rid of y? Now what I always look at is, do I have one of my values being an opposite sign? One positive, one negative. Yeah, the y's. So I might on this one choose to get rid of the y's. You're not wrong if you want to get rid of the x's. You just got to make sure, you just have to make sure that it's going to be something to work out. So I'm going to multiply this whole time by 2, this whole bottom one by 7. Does that make sense how I got that? If I multiply everything by 2. On the bottom one, if I multiply everything by 7, I get 21x plus 14y equals 70. If I were to take these two equations right here, and I just add them together right now, does anything fall out?
Y.
What's 10x and 21x if I add them together? 31x. What's negative 14y and positive 14y added together?
0.
0. What's 20 and 70 added together? So look at how nasty this x value is. And again, I'm not going to work out the whole thing, but I just want you to recognize this is definitely one that graphing sucks on. Right? So that's an x value. If I wanted to solve that x value, and again, I'm not going to do it for you because the ones tonight aren't going to be bad, I can take that x value, plug it in here, or here, and that, whatever that would result, would be my y value here. Okay? But again, they're nasty fractions that I have up there. No, this is for the elimination method, or the addition method. Okay? So again, I just wanted to give you ones that are ugly, so I wanted you to really see, because sometimes when I'm working a problem going, dude, I totally graphed that. I get that. Alright, hey, take a look at this one. If I add these together right now, is it set up nicely for us?
Yes.
What cancels?
3y.
Yeah, so I get 12x is equal to 16, right? And then I'd get x equals 16 over 12. 16 over 12, I guess I could reduce that because 4 goes into both, is 4 over 3. So I get 4 over 3 for my x value. What would I have to do with my x value to get my y value? Yeah, I need to either plug it in right here, or plug it in right here, or right here. So if I plug it in right here, I'd get this. I'm just going to show you how it plugs in, and then you work it out to get your y value. Whatever this answer comes to goes right there. Almost done. It's not time to go. Can I move on?
Yes, sir.
What about this one? Can I add these together and something falls out? If so, what falls out? The x falls out, right? If I add these together, x's are gone. So I get 3y is equal to 10. So then I get y is equal to 10 over 3. So I have an x, I have a y value, so I get 10 over 3 right here. What should I do with 10 over 3? I'm going to plug it into either one of those. You pick. I'll pick the bottom one this time. So negative 3x plus 5 times 10 over 3 is equal to 2. Whatever this answer comes out to is our x value. And again, they're going to be, I'm doing ones that are nasty, ugly fractions. Okay? All right, so using any of the methods, you get a point, x comma y is one solution. Okay, you also might get a strange answer that all the letters, which are the variables, go away. So if you get a true statement like if all your x's and y's go away, and you get 5 equals 5, that's true. They're infinite. That's the same line. But if you get a false statement like 3 equals 9, you know that's hogwash. Okay? Then you have 0 solutions. These would be parallel lines. Okay? Make sense? Everyone happy? Let's do page 141, 142. And let's do the odds. Do the odds. If you don't know which one are the odds, just do all of them, and you'll guarantee get the odds done. Have a great day, everyone. Take care of one another.
Will we get extra food?
Well, we're going to warm up on the even. I'll be proud of you if you do all.
What do you want? What do you want? Anything called.
Draw. Draw.
The quad.
What? Just like in the class.
So
What
like-
class is it?
History, first period.
Well, it's your first period. Go ahead. Get ready.
That was you mean the quad.
Just put it on up there in the folder, and I'll take
Why?
it.
You mean what?
See you guys. Yeah.
Mister, you want me to stop the recording?
Sure.